Today is the second Friday meeting of the OHDSI Phenotype Development Evaluation Workgroup. We meet twice a month, second Friday and fourth Friday. Actually, that's a topic that I want to talk to you all about also. So this is our OKRs. We are steadily marching through all the objectives that we agreed on. We want to make progress on a paper on the OHDSI Phenotype Library, which is one of the agenda topics for today. The green colors here are the ones that we achieved. The yellow ones are the ones that we're currently focused on. I think so. We have made some progress on the VA cipher work, which I see Jackie's on the call, and that also ties with our library's flow. And I think there is some opportunities to work with VA cipher to create a submission process also for the OHDSI Phenotype library. So there's some there. So that's just the high level. So we are still steadily making progress towards our key results. So for today, the agenda for today is Joel's going to talk to us about some new ideas on probabilistic phenotyping. As you all know, Joel is the creator of a tool, an OHDSI tool called P-Evaluator that helps us understand the performance characteristics of a cohort definition. So now he's going to probably use that framework, but flip it around and talk about creating phenotypes. So we are very excited to learn from him on the new ideas. And then, depending on the time, we'll talk about the dermatomyositis project led by Dr. Macaulay. We'll talk about the VA cipher progress that's happening. We'll talk about the OHDSI Phenotype Library paper, and then any discussions on global symposium. And we're looking for volunteers for that. So with that, Joel, do you want to share some slides?
Sure.
Oh, hold on one second. I see a lot of people here. Anybody who's completely new to the work group that would like to introduce themselves? I see some hands raised. So that's good. Mike Enger?
Yeah, hello everyone. I'm Mike Enger. I'm currently employed at RTI International within the Omics Epidemiology and Analytics program. I'm somewhat of a recent grad, finishing up my master's in health informatics. So just trying to get more involved and see the different avenues out there. Happy to be here.
Oh, welcome. We are all learning together. Thank you for coming, Mike. And if there's anything we can do to help you as you progress in your education, please let us know. I see Martufi Valencia.
Hi. Hi, everyone. Yeah, Valentina. I am a researcher based at SIDAX in Brazil, Salvador, Brazil. I'm coordinating a third project that's implementing the OMOP model. So basically, I'm long overdue joining a few extra work groups. I've been in the Latin America and the reproductive health work group so far. And I need to learn. I'm in this space for learning. So I'll try and contribute as far as I can. But basically, I'm here as a student to try and support the project.
You're welcome. And do you have access to any OMA person level data sets that you can run queries on?
So we're mapping ours. We're mapping some of our, we have a couple of cohorts and we're mapping some of our data from them according to project, use case basis. We tried to go all over and then it was too overwhelming to do the full cohort. So now we're just taking it kind of a project by project type of situation and
I see.
On our learning curve. So I do have some data, but we're still working on finalizing the mapping for our projects.
Okay. Excellent. Welcome. We are all welcome. Duque Neves Bernardo.
Hi everyone, I'm Bernardo from Portugal. I'm an internal medicine doctor and I currently work with the data science team in my hospital, Hospital da Luz in Lisbon. I recently presented a small work at the OHDSI Europe Symposium where we tried to follow an approach of Joel Swerdel about probabilistic phenotyping with a couple of chronic conditions. So I'm here to hear your talks and to learn with you.
Excellent. And is there a certain disease that you're interested in as part of your research?
At the moment, our project concerns multimorbidity, so pretty much the most common chronic conditions, not one in particular at the moment.
And your data, and you do have a data source that's in OMAP format.
Yes, we have a recently converted database of our hospital to the OMAP common data model. That's right.
Oh, excellent. And do you mind sharing a little information about the data source, like how many people, how long is the data per person?
Yeah, so at the moment, the conversion is still incomplete. We have pretty much a first version, but it's about 15 years of one hospital and about 1.2 million people. But the majority of the data is very incomplete. So we, in terms of having more information, it's a smaller sample, about 800 people. That's the number that we analyzed.
Excellent. Okay. And I see one more hand raised, Jacqueline Stocking. Do you want to introduce yourself?
Good morning, Jackie Stocking from Northern California, University of California. I am not necessarily newer to the group, but it's actually time for me to start learning now. I have a data set and a grant, and I need to figure out how to do the mapping to the common data model. And I also need to figure out how to do some phenotyping with regard to the whole perioperative OR to ICU continuum and adverse surgical events. So happy to be here and I'm eager to learn.
Excellent. Welcome, Jackie. And are you aware of the perioperative work group that Dr. Evan Minty is leading?
I am, yes. He's been kind enough to let me be part of that group. So I've been to a handful of meetings now, and that's a fabulous learning forum for me as well. Thank you, Gautam.
Great, great. Awesome. Okay. Oh, I see one more hand raised. Daria Zuko.
Hi, everyone. My name is Daria. I'm part of Odysseus, and I've been following your group for a while, just the recordings, and this is the time for me to participate more actively. I've been involved with phenotyping as part of our work with Atlas for our clients, and I would love to become a more active contributor and learn from you and be part of the group. Sorry for no video today. I have a bit of a poor connection, but I'm hoping next time it will be a little bit better.
Welcome, welcome. All right, okay. Joel, it's all yours.
Great. Good morning, good afternoon, good evening. Okay. So what I want to present to you, let me just go up. What I want to present to you today is some of the thoughts we've been having on probabilistic phenotyping. I've submitted an abstract and was accepted for a talk at ICB. So these slides, well, may seem a little bit formal, but this is the start of my ICB slides. So just get a little background. So we typically use rule-based phenotype algorithms in what we're doing. That's a lot of what we're doing in the phenotype space, especially in this work group. However, we see especially with Evaluator, we see that the performance characteristics of these phenotypes are sometimes lacking, especially in sensitivity and positive predictive value. Depending upon the phenotype, some would have, probably, lower sensitivity than we might like. Probabilistic phenotypes are an alternative. They're not new. I don't know if Juan's on the call, but Juan Banda and his group and his work at Stanford and all have been working on probabilistic phenotypes for a while with the Aphrodite tool set. And we're looking to build on some of that work with some of the stuff that we're doing here. So for this study was to use was to test the probabilistic phenotyping as a methodology. And in this case, I'm going to be showing an example of it in angioedema. And angioedema, for what you don't know, for those who don't know, is what's called a painless swelling under the skin triggered by an allergic reaction. Goes through some of the methods. So this is what a typical rule-based phenotype would look like. You have somebody with a condition of angioedema, you pull in their ICD-9, ICD-10 codes, you apply it during a certain period of time, and you pull out all the subjects in the database who satisfy those criteria. Probabilistic phenotyping, on the other hand, uses in this case, uses a LASSO regularized regression algorithm to determine the differences between essentially cases and non-cases. And it comes up with a set of covariates and weighted with a beta coefficient to be able to determine who has the probability of someone with the condition of interest. So in this case here, the regularized regression might give you things like angioedema, just to look for allergic disposition, emergency room visit, prednisone, all those things with all the different weights from the betas. And please feel free to stop me. I'm not and ask questions whenever you want. I can't keep a hold of the chat. I can't look at the chat too well, but if you ask questions in the chat, maybe if somebody can help pull those out.
It certainly looks like angioedema predicts angioedema in this toy example, but emergency room visit as a strong predictor is surprising. Probably because of an allergic reaction or allergic disposition.
And that's generally what, you get a swelling and you go to the emergency room. Yeah.
Thanks.
And that's when you get your epinephrine. So just to go through some of the steps that we might do. So rule-based phenotyping, you create your rule-based phenotype algorithm, and then you find subjects in your time at risk in the cohort of interest. The probabilistic one, it starts off with, and I'm going to go through this a couple times. You can please feel free to ask questions. What we call it using a noisy labeled positive and negative controls. So we take people who we consider to be cases, people who we consider to be not cases. We know that the labeling is noisy based upon the algorithms that we got the subjects out, but we see a lot of leniency with the LASSO regularized regression being able to winnow between determine the cases and the non-cases. And it's what we call a supervised learning probabilistic model that comes out of this. Once we have the model, we then apply the model to at appropriate time points for each time at risk for each subject in the cohort of interest. So in this case, a cohort of interest, what I was testing here was a bunch of times at risk for a drug exposure. And, for instance, we might use an ACE inhibitor, captopril, and pull out all the subjects during their time at risk while on captopril. So we have a bunch of subjects, we have a bunch of time that they're on captopril, and then we search for possible instances of angioedema during that time at risk for each subject. Once we've analyzed each subject, we pick the highest probability among the different time points within the time at risk for each subject. And then what we're doing is using a designated cut point. We might use 70%. In the example I'm going to be giving today, we actually found that 67% was pretty good. Determine those with the outcome. Just to go into a little more detail, and I'm not going to go
can I ask you a question on that before you
absolutely
go on? So would it be fair to say that when you talk about known cases, I mean, you're essentially using a rule-based phenotype as your source of truth for your accuracy on your probabilistic phenotype?
Yes. Yeah. Okay. So I'm using this is sort of following from somewhat of the p-valuator model, where we're using the X-spec cohort, people who we feel have a high probability of having the condition of interest as the cases. And people who don't have, so for instance, if what we're looking for in the X-spec would be, if you had 2 codes of angioedema in a single day, we feel like you probably have a high probability of having angioedema. And if you don't have any codes for angioedema during that time period, we feel like you probably have a very low probability of having angioedema. So those become the cases and the non-cases, and we put those through the PLP, the patient level prediction framework, and it determines the probabilistic model from there.
Hey, Joel,
Joel,
what is the time at risk during a rule-based phenotype? Is it just like during an observation period, or is it within some study population?
Yeah,
Usually,
it could. Yeah.
yeah,
I mean,
usually when I think of like when to identify a phenotype in a database, it's like their time at risk for that is just when they're observed.
that's true. But we could also winnow that down to be when they're observed during a exposure of interest.
Okay.
So we might use that.
Yeah, and that makes sense in the probabilistic sense, but I was unclear on how that, like what a time at risk definition for a rule-based phenotype would be. But I get it. It's like during an observation period or within some other cohort.
Within some time at risk.
Got it.
And Joel, what is the prediction window for the probabilistic phenotype?
Good
Are you
question.
following the same? Okay.
And here we go. So this sort of gives this timeline here sort of gives the idea of how the probabilistic phenotype is or the probabilistic model is determined. So we have the positive and negative controls here, and they have a start date of when we want to as an index date. For angioedema, which is an acute event, we generally have a time frame of about 30 days, broken up into 3 different prediction windows. The 3 different prediction windows sort of help aid in the accuracy, as different things might happen in the first 10 days versus the next 10 days versus the next 10 days. So this is what the model does. So the model looks at all the different predictors, all the different characteristics or elements within for each subject within these different time windows after the index date, and then uses those to create the model.
So it's similar to Phi-Valuator in the sense that the prediction is based on treatment and prognostic factors rather than items before the.
That's right.
Okay.
Exclusively after. Yeah. So you have to have it after the that time. This gives a little more detail of what we might look at. So let's say there's these 3 subjects. The green is their start of their drug exposure, their time at risk, and the red is the end of their drug exposure, the end of their time at risk. And then we look through all the different elements within their time at risk. And so one of the things that we did here to sort of speed the process up a little bit, we don't just take, so this is their whole time at risk, and their angioedema could have happened anytime in there. One of the things we want to be careful of is that we don't want to just look for an angioedema code, or else we're doing the same thing as a rule-based phenotype. But we have other elements, like Jamie pointed out, emergency room visit, or anaphylaxis, or adverse reaction to a substance. These were all elements in the model. So what we did as an innovation was to use the elements in the model and look for those elements, any of those elements, and it could be several hundred, within this time at risk. So they don't necessarily need an angioedema code. They could just have a diagnosis for adverse reaction to a substance, and we don't want to miss those people. So like I said, we use the elements within the model, because if the other thing is the way that they essentially score points for their probability of having the disease is having the elements that are in the model, because the elements in the model control the probability. If they don't, if they have elements that aren't in the model, they're not adding to it anyway, to their chance of probability. So we only look for stuff that was in the model to begin with. So that helps to narrow down the things that we're looking for each of these subjects during all these different during this time period. So for this person, they might have had this is their beginning of their drug exposure, day 0, and day 5, they might have had a prescription for prednisone. So we would mark that off. Day 5 would be a possible index date for this person. On day 15, they might have had a diagnosis for angioedema. Day 15 becomes another possible index date. 22, another one. 23, 33, another one. And at each one of these points, we run the prediction window of the starting of the 30 days. So I think I might have that. Yeah. So So for instance, for this one here, the same person, we see all these different elements at all these different time points. So at day 33, we run the 30-day prediction window at day 33. We also do it at day 22, at day 15, day 5. It becomes a little computationally intensive, but it turns out it's not as bad as you might think. So for this in this hypothetical example, this person had these 4 different time points that we looked at. It developed 4 different probabilities based upon those time points, and we selected the highest one, 0.95, as the probability of this person having angioedema while during that time at risk.
Is this a better framing, Joel? Is this the probability of having the disease versus the confidence in confirming a disease? Would it be possible that in this particular case, on day 5, a clinician who's reviewing the patient may suspect them but cannot confirm it, so their confidence is lower, but as they accumulate more information about the person, they can confirm it.
Yeah.
So their confidence goes up, but the true date was actually day 5.
It could be, yeah. I mean, it's we do have that element there, and that's something we might tweak in future iterations of this. We see how we want to do this. We might look at things like, if we see it rising right before, maybe we want to say that the index date is that, but still use the 95% probability. That's a good point. So in the analysis that I did, that I'm going to be showing you the results for today, we looked at 5 administrative claims data sets. We tested a rule-based algorithm where there was an occurrence of a diagnosis code for angioedema. We looked at the probabilistic phenotypes and examined them at different cut points. So different cut points are when we want to say, based upon, reaching this certain cut point, let's say 0.75, everybody who has a probability of 0.75 and above, we consider a case of angioedema. Everybody 0.74 and below, we consider not a case. So the question came in is like, well, if it's variable when we're going to do this, or what cut point we're going to use, how do we know which is the right one? And that's that was sort of a challenge that Martin Schumi put to me when I first proposed this to him. And the idea was, I'll show you what my idea was to sort of test this. What we did, so for this case for angioedema is a known side effect, adverse event of antihypertensive drugs, especially ACE inhibitors. So we looked at 7 antihypertensive drugs and 2 anti-diabetic drugs, 2 DPP-4s. It was you kind of think of it as a convenience sample, and the reason why I did this is that I wanted to compare the results from randomized clinical trials to see how the results from this probabilistic phenotype worked as far as accuracy in determining an incidence rate or an incidence proportion. We performed the analysis between 2010 for data from 2010 and 2023. To evaluate the probabilistic phenotype for angioedema and to test the different cut points of what we might use, the first thing we did was we extract, like I was saying, the incidence estimates, either an incident rate or an incidence proportion from the randomized clinical trials and their 95% confidence intervals. Now, randomized clinical trials, people might consider, we were looking for data to compare, and these seem like fairly good estimates to use. They're well regulated, they're randomized. People are under surveillance from the clinicians and managing the trials. So it seemed like a good place to be able to say, if we can sort of pick a level of truth somewhere, this might be it. We also computed the, so from there, we took the incidence estimates from the clinical trials. we computed the incidence estimates from both the rule-based and the probabilistic algorithms, and we tested whether those estimates fell within the 95% confidence intervals of the results from the clinical trials. We also assessed the positive predictive value and the sensitivity for both the rule-based and the probabilistic phenotypes using the pHeValuator tool. So just to show you some of the results, so these were the trials that we used. You can see there's a bunch of ACE inhibitors and calcium channel blockers and angiotensin receptor blockers in the list. We also have a couple of DPP-4 inhibitors, saxagliptin and sitagliptin. What this graph is showing is this is the incidence rate or incidence proportion that they showed in the showed it within the clinical trials, and the 95% confidence interval. What we have here in the diamonds are the results from the rule-based phenotype, and the stars are the ones from the probabilistic phenotype. Green is indicating that it's within the 95% confidence interval. Red means it's outside the 95% confidence interval. What we found was that for probabilistic phenotypes, 77% of the results from the average across the 5 databases that we used fell within, for the probabilistic, 77% fell within the 95% confidence interval, whereas only 23% of the rule-based averages fell within the 95% confidence interval. So in this case, angioedema seems to be seems to be underreported relative to the clinical trial results and relative to the rule-based results. I'm sorry, the probabilistic results.
Joel, did you compare the people that were identified with the probabilistic model but were not identified by the rule-based model, and see if they truly are cases?
Yeah, to see whether the probabilistics truly are cases. Is that what you're saying?
Yeah, the probabilistic only. So they were missed by the rule-based.
Yeah.
It sounds like the rule-based is underestimating
that
sensitivity errors. So then the probabilistic is identifying people. It's claiming that rule-based is missing those, but what's the PPV on those?
Yeah, well, good question again. So we have yeah. So we have from the we did look at the sensitivity and the positive predictive value for each of the probabilistic and the rule-based. The probabilistic phenotype had significantly higher sensitivity and somewhat higher positive predictive value compared to the rule-based phenotypes. So this was, one thing I want to say, this was a particular cut point. Just to make the data a little simpler, this was for the 0.67 cut point. So anybody who had a probability of 0.67 or above was considered a case. Anybody below 0.67 was considered not a case. One of the things that we did find was that, so like I said, better sensitivity and positive predictive value for the probabilistic compared to the rule-based. The other thing that we did find is that if this was taking all comers for the rule-based. If you took just the rule-based that had a probability of greater than 0.67, which you might want to accept, this was actually, that cuts this down even more. So a lot of these numbers here were for people who had low probability based upon the model that we were using. 0.67, it wasn't just kind of drawn out of a hat. A lot of times in validation studies, you'll have two clinicians looking at a chart review for a subject to be able to determine the probability that somebody has it. If they agree, then if they agree that they have it, then it's a case. If they agree that they don't have it, it's not a case. If they don't agree, one says a case, one says not a case, then they bring in a third clinician sometimes, usually, and then that's the deciding one. So that's why I sort of think that 0.67 is not an unreasonable number to use, because that's what's been done in traditional validation studies. Aza, you have a question?
I have a few reactions. First, it could be like one of the interpretation of this. It could be that the actual incidence is actually truly less than what the clinical trials are reporting, given that you're looking at a clinical trial population versus everybody in the database who's been exposed to a drug, which is generally one could think, oh, they're less thick generally, so their outcome, the incidence of an outcome like this could be truly less than that reported by the incidence rate, and it's not a issue of measurement error versus it's an issue of generalizability, if you would think. That's one thing, which could be true, could be not.
Yeah. Okay.
Yeah, those population compositions are definitely different.
Exactly.
It's true.
And you could think that you see how the diamonds are drawn on the right side. You would think that, well, that's not a measurement error. That's actually differences between the two populations. Yeah. But it's big. It's huge. Like the other thing I'm thinking, just for clarity, the table you're showing at the bottom, which is the performance of the probabilistic compared to the rule base, that's using p-evaluator, correct?
Yes.
Which is, of course, you're going to get much better performance for the probabilistic, because it's almost like it actually should be like perfect, because the truth is the probabilistic and you're comparing the truth, but you're showing the 0.67. So you're showing so that's the best you can get. The third point is, given that you're showing here a generally a lower estimates of the incidence using a rule base, and a low performance in terms of, this is where I'm confused. You're showing that the rule base is having a low sensitivity. At the same time, you're showing that it's giving us a lower estimate of incidence compared to the rule base, to the probabilistic. So I can't put these two things together. If it has a lower sensitivity, then if anything, any acceptable PPV, then if anything, I should expect that the incidence should move towards right. No, I'm confused. Hold on. It's low sensitivity. No, that's right. So it's low sensitivity, then it is going and underestimates all that. That's right. So that's in the right direction. So my question is, then does this suggest maybe I should use 2 diagnoses, since that's the X-spec and seems to work good for your, no,
well,
it would be the exact opposite. Yeah.
So the X-spec would be, that the X-spec would, if you use 2 diagnoses, you shoot down the sensitivity even more. Because you get there. I mean, you get your higher positive predictive value. We just use that for the cases. So this is using them all. One of the things that, going back to your point about the differences in populations, we thought about this a little bit. The thing that I like about angioedema is that it's an allergic reaction, and maybe some of the clinicians here can tell me whether this is right, wrong, or indifferent. It's more of an allergic reaction, so it's not necessarily based upon, if you compare 2 people with, one has hypertension, diabetes, and hyperlipidemia, the other one's perfect condition. Their allergic reaction to something isn't really dependent upon their comorbid conditions. So in this particular case, I'm thinking that the differences in populations between what we have in our what we have in our databases and what we have in what we're in the clinical trials may not make that much of a difference. Like I said, it's an allergic reaction. It's sort of a, I would think it's more unrelated to comorbid conditions than other things. If we were talking about maybe acute kidney injury, that's something different.
So-
Then populations wouldn't have to be more similar.
Yeah, I can make one comment about that particular topic. So, in many cases, so a rule-based phenotypes usually relies on a label of angioedema that is manifest in some code. The use of the label has a purpose. It is usually to justify a certain treatment. In many cases, in clinical practice, patients get treated for angioedema even though they may not have a label of angioedema because they're suspected to have angioedema without a confirmation. They may have itching and maybe a little bit of swelling, maybe not. But the treatment doesn't change. It is usually discontinuation of the drug. If they suspect that it's ACE inhibitor that is causing angioedema, then the treatment would be discontinue the drug and see if you get better. So for me, actually, the real question is, among the people that were identified with the probabilistic, how many people stop ACE inhibitors? If you observe that most people continue to use ACE inhibitors after they have angioedema, that's not consistent with the treatment of angioedema.
Yeah, that's a good point. I'll look at that to see what proportion stopped using it between the two different
right. Otherwise, it could be people who complain of some itching maybe, and then they were given instructions that were consistent with angioedema, but they didn't think it was really angioedema, so they didn't discontinue the drug.
Yeah. Yeah, one of the things that some of the models that we show, edema came up as one of the, and urticaria, rash came up as some of the things. So, so some of these patients are having some reaction to the drug of some sort. When we create our angioedema rule-based phenotype, we don't want to put in a whole lot of things like edema because it would make it too broad. But maybe they're getting labeled as edema and they're giving them epinephrine and moving on. Hey, Jamie.
Yeah. What is so the x-axis incidence scale looks linear, so that's good. But what's the person years denominator or person time denominator? Because I'm kind of getting at, so I'm looking at sitagliptin looks like it is the largest difference between the rule-based and the clinical trial. It's like, is that a meaningful difference? Like, is the person time denominator small or large? Is it like per 100 person years, per 10 person years, or like a million person years? Because like it might be that these differences aren't even clinically relevant, and that's why I need to know what the denominator is and what the clinicians on here think. Like, these are indeed big changes, but it kind of depends on what the denominator is.
Yeah, so it's sort of a mixed bag in there. I sort of simplified it for the graph. Two of these are, and I don't remember which one. Two of these are incidence rates, and the rest of them are incidence proportions. So that most of them are incidence proportions.
Okay.
So it's percents.
Got it.
And two of them were incidence rates. I think sitagliptin was actually an incidence rate.
Okay. So is it like per how many?
Per 100 person years, yeah.
Per 100 person years. Okay.
Yeah. That's the sort of the similar.
So then for sitagliptin, the difference
percent
between 0.2 and 1 per 100 person years that is a clinically meaningful difference.
Yeah, I guess we're looking at.
So these differences matter, is what you're saying. The incidence proportions, I get it. Okay.
Yeah, I mean, if we're looking at if we think about RCTs as close to the truth as we could get, and we want our phenotypes to be as close to the truth as we can get, as little, and you're the expert in this, as little misdiagnosis as possible. Getting closer to what we think is the truth is what we're looking for.
No, of course. And like that Ernesto one where like 0.1 incidence proportion to 0.6 incidence proportion is not trivial. I get it.
That's
All right. Thank you.
Joel, is that the meta analytic incidence proportion rate, or is that one data source? What are we looking at here?
It's an average of the 5 data sources.
But how did you get that average? Is it simple average, or
Simple
did
average,
you?
yeah. Simple average.
Okay, so there's a huge thing here, which is the age gender effect,
Yeah.
which we know is like gigantic, and knowing those data sources you use, they're gonna, like, simple average would be a little bit, and without like adjusting for age and sex would be, can completely flip the story.
Yeah, yeah, it's true. But we're looking at, the only thing is we're looking at it in both of them. So we're using the same populations in both of the groups. So there might be differences. So we do see that some of our population is below 65, and some of them are above 65 in the thing. So while that will make a difference, that's why we use multiple data sources. So they tend to, hopefully balance each other out.
I hear what Oz is saying, though, in terms of like the diamonds and the stars as simple averages versus a meta-analytic result, and not having age sex adjustment is a criticism that you might get.
Yeah. Yep. That's why I'm doing this here. Before
This is also probably the only place we'll get criticism.
And also, Joel, a simple average will be problematic given that we know the heterogeneity across the data sources, and like you can easily do the random model and get the meta-analytic estimate, which would be at least. And also, just to tell you that average is a really, if you put the prediction interval out around that diamond, given the differences I know exist in our data sources, that prediction is going to totally overlap with your confidence interval. So it's the same problem with using that average, assuming that we have that certainty of that point estimate, and make inferences on that.
Right. But still, the point estimate is what we're using, and we're still using those. When we do something, we're looking at we are getting the incidence rate from that. And we're getting, we'd still be getting higher incidence rates, even with the while they might overlap, it's still, like we said, closer to the mean.
So like I think despite the statistical pieces that Ozza introduced and are clearly an issue, this is like to me this is an amazing like first scoop at comparing these rule-based versus probabilistic approaches. I think that the evaluation component probably needs some additional love, but this is showing that there's possibly a great difference between how these two compare against each other given a truth.
Yeah. Thanks, Jamie. At Odyssey, I've submitted one that's going to be angioedema. Plus, I've also looked at now hypotension, which was another element that was, as a convenience. It happened. They gave adverse events of hypotension for all the antihypertensive drugs. So I was able to do a comparison there, and we see similar results.
And then lastly, these are all the rule-based and probabilistic phenotypes that you created. These are in 5 US claims databases?
Yes.
Okay. And some of my work has shown that like incidents across those databases, or at least the measurement errors across those databases, are all pretty similar. So like might be valuable to do this in ex-US databases as well, just because that's where a lot of variability happens in terms of measurement errors and just incidence rates.
Okay.
As we learned from that Odyssey AESI paper, which is, like all incidence studies, in my opinion, should be like based on what we learned in that.
Yeah. No, good point. Yeah, that's what we like. Yeah, that's our at Johnson & Johnson, our ex-US data sets probably wouldn't support it because they're general practitioner ones. Angioedema is sometimes usually an emergent outcome. But we might be able to do that in some network studies. It's just the beginning of this probabilistic stuff. That's what I'm hoping to start building on from here.
Mm-hmm.
Any other questions?
Because like looking at this and taking it at face value basically says strongly that thou shalt do probabilistic phenotyping, and I think there's like more to there's more to do before making that.
Yeah, there's a lot. There is a
conclusion.
lot more to do.
Yes.
Yeah, nobody's switching overnight, but it just gives you an idea. I mean, we know that there's a lot of errors within rule-based, and it just from a face validity standpoint, if you think about the complexity of what you find in the probabilistic model versus what you're getting within the rule-based model, it seems like it would draw in, something that's a little bit closer to the truth.
Mm-hmm. Yeah, I still would like to see the discontinuation of angiotensin converting enzyme
it's a good idea.
after the index date. If not, I would suspect it.
Gautam and Jamie, and I can't access the chat. I think some people are having some comments in the chat, and no.
I don't see anybody in the chat. Yeah.
Okay.
It's just my comments from the peanut gallery. There was one earlier that Will Kelly asked, but that was about I think Chris's study package.
That's from last week.
Oh. Yeah, the comments in the chat is just me making nonsense. It's nothing.
Joel, we got 10 more minutes. Do you have anything else?
No, that was it.
Awesome.
Do we want to have Gautam? I still want to, anybody else? Because I don't want, make sure we didn't dominate the comments. Juan, anybody else have any reactions? Okay.
Thanks, folks. Appreciate the time and all your comments.
Great.
Joel, can I add one point to Joel? Even if when you discuss those results, and assuming you're going to do this across other outcomes, not one, because somebody will say maybe that's an angioedema thing.
Right.
But if you do it across, say all the phenotypes we have, or focus on DMEs or whatever, and you see the same trend. If you can't make the argument that that probabilistic is the way to go, you can at least make an argument that seeing consistency between fee-evaluated estimating a low sensitivity of a rule-based and a similar and a corresponding trend of lower incidence rate compared to a given truth that's coming from clinical trial, you can at least argue that this show that sensitivity estimate out of fee-evaluated, which is the probabilistic approach, at least give you a sense of truth of the true sensitivity. If you want to use the probabilistic model, you can at least use it as a gold standard, because the results are consistent with the trends being lower estimate when the sensitivity is estimated to be low.
Yeah, no, that's a great point. Awesome. One of the things I happen to be, one of the ideas I thought about was looking at rhabdomyolysis and statins, because it's a common, well, not a common, but it's a adverse reaction that you see in statins. One of the things I found is that it tends to go in the reverse direction, at least, and that's just preliminary data, that rhabdomyolysis is in rule-based is much higher than probabilistic. But still it's more closely following the clinical trials that have very low incidence of rhabdomyolysis, but people are going into, you wonder whether people are going to the emergency room saying my muscle, I'm having muscle weakness or muscle pain, and after they start statins. I think I think we've all probably heard of somebody who has rhabdomyolysis from or claimed to have rhabdomyolysis from statin use, had to switch statins or any of those things. But according to the clinical trials, it's almost non-existent, very few. And the rates that I saw with probabilistic are in the single digits of 10,000, 2 or 3 per 10,000, and by rule based it was like 2 or 3 per 1,000, like a 10-fold difference. I just thought that was an interesting difference. Here we see angioedema, we see low, but rhabdomyolysis we see high.
All right, Joel, I want to go through the rest of the topics.
Yep. Thanks.
Chris, if you're on the call, do you want to give us an update on the dermatomyositis study? Is he on the call?
So Chris actually had to drop off, but I can share an update real quick. So our data partners at Columbia were able to run our refactored study package. However, and we are still waiting on our IRB approval, which we expect to happen next Tuesday is when our IRB is slated to review it. So we have not been able to unseal their results. So we are chopping at the bit to get that IRB approval so that we can take a look at their results and see if they're what we expected. I think you and Chris have been working behind the scenes on the J&J.
Okay, great. Thanks, Bill.
If I recall. But
yes,
other than that, no real updates.
Great. Thank you for the update. Any questions to Bill or any other data partners who want to give an update? I can give an update from J&J's perspective. We are still waiting on the final formal approval, but I'm expecting us to be able to support the study.
Yeah, and also it was determined to be low. What do I call it? The approval process is very. It's the simplest we have in the system, so it should be coming in the next week. It's just administrative, giving us an ID and the green light.
Excellent.
I think I saw Jackie on the call from the VA. If you would like to give us an update on the subgroup.
Oh yeah, our subgroup met for the first time yesterday, and we just went through the process for entering phenotype metadata in our VA Cipher library, and we're planning to pilot several phenotypes from the OHDSI group in that system. So if folks are interested in joining, we're meeting in 2 weeks to discuss that further.
Great, thank you. Quick update on the OHDSI Phenotype Library paper. This is something that Juan and I made progress late last year and then early this year. Want to get it to some submission, at least in preprint format, so it can be referenced in upcoming AMIA symposium, I believe. So I'm going to try to make some progress next week on that topic. It's an open document. If anybody else wants to be involved, please ping me or Juan, who are helping move this paper along.
I have gotten an update. I don't think I actually informed everybody. Now I'm busy because the news came on a Friday evening, and we got our heterogeneity assessment, the Phenotype February of 2024 paper got accepted into AMIA. I will send out. I never send out all the acceptance letter and the revisions we got. It was accepted as a full manuscript, so it's gonna be published in AMIA, JAMIA correspondence as a full manuscript, and we got 15 minutes to present it in the main conference in November. And the revisions we got were very, very positive, very nice. Few things that reviewer 3 asked for that we will be working on to get the final version of the manuscript by the end of, I guess, August 15th is the deadline for the revisions. So that's a collaboration from all the community and this work group in particular. And we aimed for AMIA and we got it. And so congratulations, everybody.
Yeah, congratulations, Asa, and congratulations for the Phenotype February work group. And then the Global Symposium. So we do have an hour for the work group at the Global Symposium, and we still have to stay in the early stages of planning for it. Any volunteers from the work group who would like to be actively engaged or involved or even lead parts of this session. So it's basically calling for volunteers.
So we have a 1 hour work group meeting. Is that what you're saying?
Is it more than an hour?
No, it's a half a day. So it's very similar to last year. We have many ideas of what we can do, but one thing we could do is talking about the different innovations that are happening this year across the different individuals. So we can talk about that. But yeah, we need to draft an agenda. Yeah.
I'm volunteering to speak about the next steps of the Phenotype February incidence rate incidence rate adjustment work. That shouldn't be more than 20 minutes of presentation with some discussion.
Okay.
That is not even remotely close to half a day, but it is in addition to what was what was accepted to AMIA, there's more work to do in that, and I'd like to share that with you all and then discuss it.
Excellent. Andre, did you want to say something? Your hand was raised temporarily. No.
Oh, if there's a way to help,
Gotta go join next meeting, friends. Bye.
All right.
Thanks for the chat.
Thank you, everybody. Have a good day.